Right, today we're going to talk about elastic collisions. Now, as we know, during collisions, take it as there is no external force acting on the bodies. Now, and what's so special about elastic collision is that kinetic energy is conserved before and after the collision. And as we know, for all collisions, if there are no external force, the momentum is conserved before, during, and after the collision. Now, we are going to use this to solve a problem of elastic collision. We have a question here. An object X of mass 1 kilogram moving with a speed of 10 meters per second collides elastically head on with another object Y of mass 4 kilogram moving with a speed of 5 meters per second in the opposite direction. We can see this in the diagram. What are the velocities of the objects X and Y after the collision? Now, to solve this problem, we will make use of the conservation of momentum, which is mx ux plus my uy, which is the initial momentum, total momentum, equals to mx vx plus my vy, total final momentum. Now, the other equation will be the relative speed of approach instead of the conservation of kinetic energy, which is this equation is actually derived from that and is easier to solve. Vy, relative speed of separation, Vy minus Vx. Now remember, momentum and velocity are vector quantities, so when you sub in the values, you have to be very careful. First of all, you're going to set a direction as positive, and in this case, normally we take right as positive. And let's label these equations as equation 1 and equation 2. And let's make this a little smaller, give us a bit of space. So equation 1, we sub in the values. 1 times speed of 10 plus mass 4. But now please be careful, the velocity is in the opposite direction, so it's minus 5 equals to 1 Vx plus 4 Vy. And for equation 2, we have 10 minus 5 equals to Vy minus Vx. So we have two equations. We're going to solve this simultaneously. And so we have equation 1 again. So simplifying it, we have 10 minus 20. We have Vx plus 4 Vy. And equation 2, we have plus 15 equals to Vy minus Vx. So with these two equations, we will solve this simultaneously. And what we're going to have is equation 1, we have minus 10 equals to Vx plus 4 Vy. Equation 2, we have plus 15 equals to Vy minus Vx. Now if you take equation 1 minus or plus equation 2, what we'll have is we have minus 10 plus 15, we're going to have 5, and we have Vx plus minus Vx, they'll cancel each other, and we'll have 4 Vy plus Vy equals to 5 Vy, and Vy will be 1 meters per second. And since it is positive, obviously it is to this direction. And if you solve for Vx, sub into equation 2, you're going to get a value of Vx equals to minus 14 meters per second, which tells you that x is going to move in this direction. So there we have it, how we solve for problem of elastic collision.